Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Zigbee. So let's dive deep into it. So what exactly is the need that we are fulfilling with Zigbee? Well, reality is that we are installing more and more stuff. Now, what are these stuff? These stuffs are basically I/O devices, meaning they can either collect data or act upon it, meaning it can turn on or off something. And most of the time, it can collect data, be it temperature, humidity, whatever have you. And we are going all in onto it, meaning early days it started with the industry, but now it has reached to households, schools, hospitals. So we need something that can handle this ever expanding network. It must have very low power because here still we cannot use wire because it will become a wire mess, and it would be way too expensive, way too uncomfortable to physically do. So we have to be wireless, but again it has to be battery power, so it's small and easy to conceal. Conceal as in, like, just put it and forget it. It should not be like a mobile tower everywhere. So low power draw is compulsory, and low power draw is also required in some other ways. Like, imagine this. Well, let's say you put boatload of sensors in your school, because you do require in school, especially CO2 monitors, because you have way too many kids respirating, as in like they're doing like this, meaning the CO2 could literally go to few percentage. Now, of course, lethality happens at very high, around 13%, 10+% people say run away. But let's say you're not there, you're not even in the yellow range, but you can reach a point where every kid is unnecessarily tired. It's like, why? They are not getting oxygen, there is too much CO2. So you do need a sensor. Now imagine if you put a lot of sensors and each sensor is consuming too much power to communicate data, your power draw of the building will go up. So fundamentally it has to be very low power, because we are expecting to put hundreds of these puppy. So low power draw, wireless, and that's what we are looking at, and must have good network robustness, because once you start to amplify the numbers, you have to realize very early on that Wi-Fi is not designed for that. Meaning you can have a very good Wi-Fi router. Your ISP one is generally not that, but let's assume you have a okay one. It cannot handle hundreds of devices. It will barely handle 20 or 30 devices properly. It's not built for that. It was designed for few trunk load connections, meaning your PC, your laptop, your mobile phone, not for, like, hundreds of small devices going tick 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 tick. It's not built for that. So we needed something that has good network robustness and low cost. It has to be cheap, otherwise how the heck we gonna buy a boatload of them? And wide supports is a must. Now this is a critical aspect. Why do you think your Wi-Fi works? Because a lot of company got together, made a Wi-Fi alliance, and that Wi-Fi alliance makes sure it's compatible with everything else. So you buy a Samsung phone, you do not have to worry about whether you have TP-Link or D-Link. It just works. So we need something like that. It cannot be proprietary. It has to be something universally used, so to say, or as close to universal as possible. Low cost, and these are the requirements, these are the checklist we started in 1990s. So Zigbee came to the fray. Now this is a low power, it's a very low power, meaning it can run on the coin cells that run your watch. Digital radio, it's not analog. Back in the days we did try some analog stuff. So this is a digital system. Wireless PAN. Now this may sound counterintuitive. PAN simply means personal area network. Like Bluetooth is a PAN network, Wi-Fi is a LAN network. So but what about the range of this thing? Well, range wise it's counterintuitive why we say PAN, but it has very large range, and you can expand it to as large area as you want, as long as you're building it properly. So size wise it's not an issue. We just call it PAN because it's inherently has very low data rate. It's not designed for transferring even video, audio. It's not like even audio, it cannot go through this. It's designed for sensors basically. That's how the foundation was laid in, like, early, let's say 90s. You had a cement factory or any water plant. You have hundreds of sensor requirement. Now if all of them are wireless, it's super easy to deploy, super easy to maintain. And even if they are battery powered, and let's say the battery should run for 2 years, you can literally have a scheduled maintenance where it's like every 1.5 years you just swap all the batteries. You do not even give it amount, just swap all the batteries. So but the data that is sending would be very low bandwidth. It would be like, temperature this, temperature that, temperature this, temperature that. Nothing massive, so to say. Kilobits, not even megabytes. So kilobits, very low bit rate. Like this puppy is very slow as like a telegram. And I mean that that kind of telegram slow. It does have long battery life, of course, a requirement, compulsory requirement, because 2 years is like one of those things where people start at 2 years. Like if you are building a device that does not even last 2 years, people will be like, bro, might as well use an adapter at that point. So 2 plus here, and is security because it could be controlling something significant. Let's for example, hospital sensors also have this. So it should have enough oomph so that it can handle some serious attacks, so to say. So it has 128 bits of encryption protocols that can be utilized. So it has some security. Of course, let this be very clear. This is not your iPhone. This is not your Samsung Ultra. It does not have, like, somebody sitting down with a laptop going grrr, crunching the encryption. Of course, it will break it, but it should not be like, oops. That's the only thing they're doing. They're putting some effort into it. So, and mesh networking, now this is the critical aspect. This is why it's completely different from Wi-Fi. Wi-Fi, we are still working our ass off just to figure out, please do mesh networking. It's not a plug and play solution in Wi-Fi unless you go to enterprise level. Here it's designed from day one that every device, if it has a router functionality, can act as a beacon where it's like, twing, collect the data, twing, collect, send my data plus the data that I collected. So now you can have a kilometer size factories interconnected. So mesh network allows for that. It allows for range because hopping can happen, and it has robustness, meaning if each if you design it properly, if you have enough distribution, enough nodes to hop around, few nodes can go down and your system still would be functional. So not only it gives you range, it also gives you robustness, which is like shut out, take money for important stuff. And this puppy was conceived in 1998, standardized in 2003, and it has grown exponentially in last few years. So 350 members as of now. Which companies? Have you heard any of them? Maybe you have heard of Samsung, maybe you have heard of On Semiconductor, Panasonic, and Microchip, and Texas Instrument, TCL, and LG, and Honor, and Hawaii, and IKEA. Yes, IKEA is here for some reason. And Espressif ESP32, D-Link, TP-Link, Texas Tel-Link. Almost everybody is there. Oh, Facebook is also there for some reason. And T-Network is also there. Actually, to be fair, it has everything. MediaTek is also there. So do look into the list if you want, but trust me, it has more than enough support. That's why it solves the issue where multiple manufacturers are making multiple things. Meaning if you are want certain things that are not made by your beloved company, other company could be making it, because you can have electric meters, lighting, televisions, thermostat, television, not the bulk data, television as in controlling wise, control signal wise. You can have set-top box, smart appliances, home gateways, and all that. So there are different countries, I'm saying, companies that specialize in that. Like, because electric meter, anything that has to deal with electronics, not every company wants to touch it because it does have certain hazards. So other company would be specialized in that. Like a company that is specialized in smart appliances like LG would not be a perfect suit for microcontroller. So for microcontroller, Microchip is here, Microtech is here, On Semiconductor is there. So you see, there has very wide range of support, meaning unless you are very, very ludicrously unlucky, it should just work. It does have that kind of support. Not mandatory validation, but it's like, unless you mess up, it should just work. Now, what about topology? Now, topology, let this very clear. This is because it's so old, it's literally was running on 2.5 gigahertz. You're like, wait a minute, why didn't they change the frequency? Yeah, it's old. That time they were not expecting how strong Wi-Fi would grow. So I'm pretty sure if they were new that back then, they would have been like, yeah, we have to reduce the frequency. How Wi-Fi Halo has much lower frequency for longer range and lower interference. Yeah, this does not have that. It has like same 2.5 gigahertz as your microwave, same 2.5 gigahertz as your Wi-Fi, same Wi-Fi 2.5 gigahertz as your Bluetooth. So yeah, it's a noisy environment. So core is robust. Now be mindful, even though it was designed as a communication low cost device, it was designed from day one to be robust, because they were expecting to put these puppies in electromagnetically noisy environment. Meaning if you have ever worked around a plasma cutter, yeah, that puppy destroys wireless signal. So you have to design in such a way where you can handle that. So robustness has to be built on a radio level, like a radio protocol level. It was done that way. So it is reliable, it is energy efficient, and there are three roles, primary roles. Now coordinator is the role, basically is the master hub. It collects all the data, stores it. Now what does it do after storing it? Well, that's up to you. So your coordinator could be something like this, and it dumps all the data to your single board computer or your laptop or your server, and this will basically become the gateway to the internet if you wanted to. If you are like, hey, only keep all the data into the local network, it can do so. This will basically, this is the master hub. This is where all the data is finally coming to. Where can you read all the data? You have sensors all around the house, all around the school building. Where can you read the data? You can read the data at coordinator. Coordinator is the main daddy of the whole network. And of course, if you want to secure the network and for some reason like something bad happens, yoink the coordinator, network falls off. It's designed that way for that reason. That's why it's kind of stupid idea to have Wi-Fi connected, direct Wi-Fi connected devices on the device itself. Because if you have a coordinator, you have one point of securing that you need to do. So if you have every device that can connect, yeah, all you have is a, what we call bot attack. So coordinator is the central hub. Then how does coordinator talk to everything else? Now be mindful, coordinator also has its own inbuilt router, exactly like how you have your ISP router, but generally routers has a dedicated device set or tool, so to say, that allows network bridging, meaning this needs to listen to the sensors and talk to the sensor. Sensors need to talk to this, but if they are not in direct line of sight, a router will be used. Now routers, most of the time, if you're buying any device that is mains powered, meaning if it's directly running on the mains, they will have the router functionality built into it. So the idea is data can hop through it. So router is the one that allows the mesh network to be created. So you can have 10, 20, 30, and that allows you to have ludicrously large amount of sensors. And even if some routers goes down, generally hopping can be done in such a way that you will never have a lost packet. So router is the main reason why multipath is possible, why you have such a robust network. We are still trying to do this in freaking Wi-Fi, but this does work in Zigbee. It was built for that. So that's there. And then you have end devices. This is what most of the time when you're talking about Zigbee, this is what people are talking about. End devices. These are battery powered devices most of the time, not all the time, most of the time. Like because again, inherently you do not need a lot of energy to read temperature or humidity and CO2 and all that. You can have a coin cell, large coin cell of course, but you can keep reading it for 2, 3 or even 5 years on just one cell. Or sometimes if it's a very high refresh rate, then you may be like, hey, let's just put it on mains or some bigger batteries. That's up to you. So these are the IO devices, meaning whenever you buy something like single board computer, you notice these pins. These are your input. Either you can read something or output, you can control something. So those devices are called end devices. These are the things that do things. They will turn on and off because they are the relay devices. They will turn on your air condition. They will turn off your air condition. So this is the end goal. So you have coordinator that collects all the data, you have router that allows the network to function, and you have end devices that does thing. These three things allow you to make that mesh network. Now be mindful, not every device is just clean cut. I am the end device, that means I am the end device. Many mains powered end device would be router only. And that's why many times you will have hard time finding people just buying router. You may already have more than enough. So you do see people buying this, and of course that's the requirement. So that's the topology aspect of it. So what were the products? Now, thankfully, it's there, it's here, it's real in India also. But you do have to understand, smart home is not a healthy ecosystem, meaning your mobile phone is an ecosystem. It has three primary language wireless-wise that it talks. It has Bluetooth, it has Wi-Fi, and it has mobile networks. Even though there is a lot of enough chatter in mobile networks, it still either works or just like, hey, I'm 4G, I do not work in 5G, that's it, done. But when it comes to smart homes, it's not as simple as that because of the low cost requirement. Generally, devices only have one radio. So they can either work on Zigbee or Bluetooth or Wi-Fi or Wi-Fi Halo or some other Meta or some Thread, something like that. So that is a very big issue. So many times, same company, like let's say Sonoff, same company can make multiple devices with multiple prices because again, certain interface requires a bit more cost. So they may increase that charge, and many times you may find something that is not selling well, selling for a sale, and you will like, hey, same company, you will, oh, Sonoff, like it is the air temperature and all that, you're like, okay, I click it, then you buy it and it's like, oops, it's not actually Zigbee network. So be very vigilant. Whenever you are buying these puppies, be vigilant. Whichever interface that you want to choose, be vigilant about that. Like in this scenario, Zigbee, be damn sure. Read the freaking manual if you have to. Be damn sure that it has Zigbee. Way too many people have fallen for this, whereas like, I bought it, it does not work. It's like, it does not work because you are in the wrong network, wrong wireless frequency, so to say. So what sort of stuff you can buy? You can buy motion sensor, that is desirable because it allows you to have lights, AHD and all that that's turning on and off based on real motion. Air temperature, again, desirable factor. It also solves that issue where ACs, especially dumb ACs, where it's just like either it's too cold or too hot. It's like, what if you have good enough sensor data? So air temperature sensor can help it. And humidity. This is also desirable. Plugs, LED strips, all of those are available. Now you can even buy this outdoor weather station. Like, why the heck I want to do outdoor weather station for my household IoT? Well, the reason for that is if you know the outdoor weather, you can control your air conditioning very well. Now, of course, many of you may already know, but not everybody uses the modes in your AC. Many split ACs have modes. Many times people do not know. They just know cool, that's it. but there is a specific mode specifically for high humidity environments, especially in India when we have rainy season. It's like around 1 month long. So we have a setting, every manufacturer makes that, but many people don't know. So, but if you have a weather vane that is outdoor, it can detect that humidity has changed. It can even correlate that data based on, hey, wait a minute, for last 1 day I'm getting that excess humidity. Now it can change the AC mode to that mode that is specifically fine tuned, so it removes enough water that it feels nice, so to say. So these are little things, but again, that's the whole point of smart system. If you automate all of this, you get much better experience and much less energy waste. So that's desirable. Um and many and be mindful, many big nodes that are big powerful one, if you read the manuals, many will say like it can act as a router also, meaning you don't have to do anything. It's just like, yeah, I'm an endpoint and a router, so it will be there. If it can receive signal from someone else, it will allow it to hop it. So you can have a lot of devices that are like, quote unquote, from your point of view is just end devices, but you no longer have to spend money on routers. Sometimes it's required, sometimes it's not, but be mindful of that. So a lot of products are option available. Like you can see that like you have CO2 monitors, humidity monitors, temperature monitor, pH monitor, a lot of things, lot of things. So now we come to the final part of it. All we have talked about is a network. So how do you do anything with this network? Well, you need home assistance. Home assistance allows that right now what you have is a device that you can see your mobile phone. If you have all the network done properly, it's just a fancy remote control. You can buy a BLDC fans that has remote control. That's not a big deal. Heck, your AC has remote, everything has a remote. Heck, if you have any let's say Chinese manufacturers, many of them have Bluetooth transmitters, so your mobile phone can act as a remote for all of them. So how do you make it smart where it auto adjusts? Well, you need a brain. Now all you have is input and output. You need a brain. So brain is the home assistance part. So what is Alexa? What is Google Home? These are the brains behind it, meaning they can do things based on the input and output. So it can detect, hey, am I detecting a high temperature rise? Okay, now turn on the AC. Who does that? Who does that actual calculation? The smart home devices does that. So for smart part, you need that smart home assistant, so to say. Now you have two option. Primary option is for most of the people, just buy an ecosystem from whichever company there is, Google, Alexa, whatever have you. Other companies are also there, but be mindful at that point in time you are trusting your overlord, and I do not trust their security. I'm like, wait a minute, isn't Google the best, most secure? Here's the bridge from IoT devices to Google is not secure, and many times that's where they get attacked. And yes, there is more than enough historical data where I'm like, yeah, I do not trust this puppy anymore. Yeah, more than enough DDoS attack, more than enough hackers on like people's security camera. That happened on Amazon. Security camera is like, yeah, it's available for everyone else, where I'm like, yeah, no, I do not trust their security, and somehow I'm supposed to rely my security on their security. It's like, yeah, no. So, and be mindful, just because they are rich does not mean they are not incompetent. You will be shocked. Trust me when I say this, you will be shocked how many rich people are there. Like this company is so big, so massive, it would be absolutely awesome. It's like, you look into their IT, you're like, what the hell? So trust me. Ask an IT professional near you. Trust me, they will tell you, oh, you think we work in such a massive company, multi-billion-dollar company, multi-trillion-dollar company, our IT would be badass. You're like, no. So that's why I do not prefer this option. Thankfully, enough people got together and desire for this device has grown enough that you can buy home assistance. That is a physical software, I'm saying physical hardware and software package that can be bought. And this is free and open source. So of course, you pay for a hardware, you can run it on something like this, or you can buy a complete device, that's up to you. Use your low power PC or a single board computer to do it all. Now benefit of that is you have a single point that you control. So if it and not to mention, because it's free and open source and everything is kept in your what you call local network, you can have a very strong firewall encryption system, where it's like, if it's trying to send way too much data, because again, all the data that you're collecting is easily stored on board. Like temperature data, yeah, a lot of it is a spec sheet, Excel spreadsheet. It's not going to be massive, it's not going to be gigabytes of file, but if your firewall router can detect it, like, wait a minute, why the heck this puppy is sending so much data, it can easily trigger an alert for you, where it's like, hey, something is hacked. So it's a much more robust system where you can detect and stop something. And most of the time this is very hard to hijack. Not impossible, let that be very clear, but because these are not cost cut down devices, they are not like as cheap as we can make it. So this device would be like $10 sold to you for $200. This will be like a $300 sold to you for $500. So you actually get far more oomph, far more compute, where you can like, okay, I can run enough encryptions, enough stuff where I can detect something bad happening. So it's a far more useful approach. And not to mention, not giving control to someone else about your household, me like that. So that's how you actually take all the Wi-Fi hula la la and then actually do something with it. And that's why I said, like, this is very old. That's why it has 2.5 gigahertz. I'm like, come on, go below 1 gigahertz. But this is what it is. And this was my presentation on basically Zigbee. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.